Today we'll look at quadratic functions. A quadratic function is basically f of x is equal to ax squared plus bx plus c. Notice that for it to be a quadratic function, the highest power has to be 2, and that the a cannot be equal to 0. One form of a quadratic is called the vertex form of the quadratic. That is written as f of x is equal to a times x minus h squared plus k. If you look at this equation, you'll notice that we have 3 of the transformations that we've studied in previous sections. We have the horizontal shift by h. We have the vertical shift by k, and together these are going to determine where the vertex of the quadratic is. And lastly, we have a, which controls the vertical stretch and reflection. And if it's positive, then it's a regular quadratic. If it's negative, then it's been reflected over the x-axis. Let me draw a little graph based on these transformations. So we will have shifted this parabola from the origin over to h and k. H is left and right, and the k is up and down. I'm just drawing this in general, so we don't know where these numbers really are. And this would be where the parabola is in the plane. So we know that the vertex is called hk, and in fact that's why this is called the vertex form of the quadratic, because you should be able to look at that equation and read off the vertex immediately based on the h and the k. Next we have the axis of symmetry that goes through the vertex. So the axis of symmetry is a vertical line, x equals h. Next, if a is greater than 0, then we know that the parabola opens up and has a minimum value of k, which is the y-coordinate of the vertex. Let me draw a little sketch here. So if we have a is positive, then it opens up, and here is k, and notice that that is a minimum value. That is the lowest y value that the parabola has. That makes it a minimum. However, if a is less than 0, then we know that the parabola opens down, and the maximum value is k as well, still coming from the vertex. So here's a parabola that opens down, and the vertex is going to have a y-coordinate of k, but that is a maximum. Let's look at example 1. Find the vertex, axis of symmetry, opens up and down, domain, range, minimum or maximum value, the intervals where the graph increases or decreases, the x and y intercepts of the quadratic y equals x minus 3 squared minus 4, and then graph. So first off, notice that this is already in vertex form. We can tell that the vertex is the point based on the horizontal shift and the vertical shift. The horizontal shift is 3 to the right, so that means the vertex is at positive 3, and then the vertical shift is negative 4, so that's 4 down, and that's negative 4. One thing that you can do as soon as you find the vertex is draw a little sketch of the graph. and that will help you to determine some of these other answers. We know the vertex is at 3, -4, and we can see that the number in front of the x minus 3 squared would be, if we wrote it out, +1. Since it's positive, that means the parabola opens up. Now this graph that I've drawn is a sketch. It is not intended to be accurate at this point. It's just sort of a guide as to what's going on in this problem. Next, let's find the axis of symmetry. The axis of symmetry is the vertical line that passes through the vertex. And so that would be x equals 3. We've already stated that this parabola opens up. We know the domain for parabolas and quadratics is all real numbers. So that's -infinity to infinity. The range of the quadratic is the set of y values where the parabola is. We know that the parabola has a vertex with a y value at -4, and then every other point is above that. So that means the range goes from -4 to infinity. It does include -4, so we use a square bracket on -4. Finding the range also tells me about the minimum value. We know it has a minimum value because the parabola opens up. And recall that the minimum value of a function is the y value at some point. So here is the vertex. That means it's going to be a minimum because it opens up, and the minimum value is -4. Next, let's determine where the graph is increasing. So this graph is increasing starting at 3 and moving to the right. Remember that when you talk about increasing and decreasing intervals, you always use open intervals and you always use the x values. What about decreasing? The parabola is decreasing from -infinity up to 3. Next, we want to find the x-intercepts. Let me rewrite the equation here so that we can see it. It's y equals x minus 3 squared minus 4. Recall that the x-intercepts are where y is equal to 0. So I'm going to take the equation x minus 3 squared minus 4 and set it equal to 0. To solve this, I'll move 4 to the other side. When it moves to the other side, it moves over as a +4. Next, take the square root of both sides and get x minus 3 equals plus or minus 2. Then move the 3 to the right side. We get x is equal to 3 plus or minus 2. And this splits up over the plus and minus to give me x is equal to 3 plus 2 equals 5. And x is equal to 3 minus 2 equals 1. If we write these as points, they are the x-intercepts. So that's 5, 0, and 1, 0. Next, let's find the y-intercept. Need some more space, so I'll scroll back to the top here. So the y-intercept, recall that the y-intercept is when x is equal to 0. So we'll just plug in x equals 0. Y is equal to 0 minus 3 squared minus 4. Zero minus 3 is minus 3. That's squared minus 4. Negative 3 squared minus 4 is 9 minus 4, which is 5. So writing that as a point, we get the y-intercept is 0, 5. Finally, we can sketch a more accurate graph based on all of this information. So first, I know the vertex is at 3, negative 4. I know we have an x-intercept at 1, 0 and at 5, 0. Remember that the x-intercepts are the points of the parabola that pass through the x-axis. We also have a y-intercept at 0, 5. Recall that the y-intercept is the point that passes through the y-axis. And from this, we can sketch the parabola. Let's look at example 2. Same directions as before. This time the equation is y equals negative x squared plus 8x plus 9. Notice that this quadratic is not written in vertex form. So we need to put it in vertex form, and the key to putting it in vertex form is to complete the square. So we start with y equals negative x squared plus 8x plus 9. Notice that the lead coefficient is minus 1. We need to factor out minus 1 from the first two terms in order to complete the square on this quadratic. When I factor out minus 1 from negative x squared, that leaves me with positive x squared. And when I factor out negative 1 from 8x, that leaves me with negative 8x. Put in plus blank, and then close the parentheses on the outside, plus 9 blank. Now we complete the square on the inside. So we'll take 1/2 of 8, and that's equal to 4, and then 4 squared is 16. So we write a 16 here. Now notice that this negative is going to multiply times the 16. So we may have written a 16, but we really put in a negative 16. To counterbalance that, we're going to add 16 on the outside. Next, we factor. So we get negative, and then x minus 4 squared plus 25. So this is the equation for this quadratic in vertex form. From here, we can do everything we did as in the last example. So the vertex can easily be read off. That's 4, 25. I can draw a little sketch. 4 and 25, and here's the vertex. The lead coefficient is -1, so we know it's going to open down. We're going to have the axis of symmetry through x equals 4. The domain is all real numbers. The range, since this parabola opens down, is going to be everything less than 25 and including 25. So it's negative infinity up to 25, including 25. Remember, the range is the set of y values. Since the parabola does open down, we know it has a maximum value. And the maximum value is the y value from the vertex, 25. We can see where this parabola is increasing. It's increasing from negative infinity to 4. And it is decreasing from 4 to infinity. Let's find the x and y intercepts. So again, let me remind you of the equation. It's y equals negative x minus 4 squared plus 25. The x-intercept is when y is equal to 0. So take the equation, negative x minus 4 squared plus 25, and set it equal to 0. Move the 25 over. It goes over as negative 25. Divide both sides by -1. Take the square root of both sides. That gives you x minus 4 is equal to plus or minus 5. Move the 4 to the other side. That gives us x is equal to 4 plus or minus 5. And then split it up. You get x is equal to 4 plus 5 is 9, giving us the point 9, 0. Or x is equal to 4 minus 5, giving us the value of x equals -1. And the x-intercept of -1, 0. Let's find the y-intercept. y-intercept is when x is equal to 0. So we just plug in 0. And if you work that out, you get 9, giving us the point 0, 9. And now we can make a graph. We have a vertex at 4, 25. We have an x-intercept at x equals -1. And another x-intercept at x equals 9. We have a y-intercept at y equals 9. The parabola opens down. Another method of finding the vertex comes from the vertex formula. Given a quadratic in the form f of x is equal to ax squared plus bx plus c, the coordinates for the vertex are x is equal to -b over 2a, and then to find the y-coordinate for the vertex, you just take this value and you plug it into the function. So y is equal to f of -b over 2a. Example 3. Find the vertex of f of x equals 2x squared minus 16x plus 3. So instead of completing the square, we'll just use the vertex formula. X is equal to -b over 2a. Of course, the a is 2, the b is -16, and the c is 3, even though we don't use the c. So we get -16 over 2 times the a, which is 2. So negative 16 is positive 16, 2 times 2 is 4, and 16 over 4 is 4. So the x-coordinate for the vertex will be 4. And then to find the y-coordinate, we'll take 4 and evaluate it in the function. So y equals f of 4. And this is 2 times 4 squared minus 16 times 4 plus 3. And if you work that out, you get -29. So the vertex is 4, -29. Let's look at some application problems involving quadratics. Example 4. A cannon fires a cannonball from the top of a 50-foot castle at an angle so that the height of the cannonball in feet t seconds after firing is given by h of t is equal to -16 t squared plus 30t plus 50. Question A. How high was the cannonball after 3 seconds? So to find the height of the cannonball after 3 seconds, realize that 3 seconds is a t value, and t is equal to 3. So we want h of 3 written in function notation. So that's -16 times 3 squared plus 30 times 3 plus 50. And if you add that all up, you get 46 feet. Question B. What is the maximum height of the cannonball? Well, we know that the cannonball, when launched, is going to start at 50 feet based on the 50 that's tacked on, and since it's from the top of a 50-foot castle. The cannonball is going to go up a little bit, and then it's going to go down as time goes on. The maximum height of the cannonball is going to be at the vertex. So whatever this y value is will be the maximum height of the cannonball. So the key to solving the maximum height problem is to find the vertex. So the t value, there's no x's in this one, it's t's, of the vertex is going to be negative b over 2a. Then looking at the equation, we would have negative 30 divided by 2 times negative 16. If you work that out, you get 0.9375 seconds. So in other words, the maximum height occurs after 0.9375 seconds. Now to find the actual maximum height of this cannonball, we'll take this number and plug it back into the function. We get h of 0.9375, and we plug it into the function, negative 16 times 0.9375 squared plus 30 times 0.9375 plus 50 . And if you work all that out, you get 64.0625 feet. Part C. When does the cannonball hit the ground? So when it hits the ground, that means the height is equal to 0. So we'll take the equation, negative 16t squared plus 30t plus 50 is equal to 0. And we'll use the quadratic formula. So t is equal to negative 30 plus or minus the square root of 30 squared minus 4 times negative 16 times 50, all divided by 2 times negative 16. When you plug this into the calculator and you use the plus from the plus or minus, you get negative 1.06. This answer doesn't make sense since the time can't be negative. When you run the numbers again, but this time use the negative from the plus or minus, you get time is equal to 2.94 seconds. So it takes 2.94 seconds for the cannonball to hit the ground. Let's look at some more optimization questions. Example 5. The sum of two numbers is 20. What is the largest possible product of these numbers? So first off, let me set up some variables. Let x and y be the two numbers. And then I'm going to translate this first statement into an equation. The sum of the two numbers is 20. So that is x plus y equals 20. Next, we're looking for the largest possible product. Product means to multiply. So I'm going to call that P. I'm going to say we want P is equal to x times y. So we want to know what is the largest product that we can form with two numbers, knowing that the sum of those two numbers is equal to 20. The trick to doing this is to take the first equation and solve it for y. So y is equal to 20 minus x. And then substitute that equation into the product equation. So P is equal to x times, and now instead of y, I'm going to use 20 minus x. If we multiply out this equation, we get 20x minus x squared, and then rearranging terms, we get negative x squared plus 20x. Notice that this is, in fact, a quadratic. Since we're looking for the maximum of the quadratic, we know that the maximum occurs at the vertex. So we just need to find the vertex of this quadratic. The vertex occurs when x is equal to negative b over 2a. So here b is 20, so we have minus 20 over 2 times, and then the a, is the coefficient of the x squared term, is negative 1. So we have negative 20 divided by 2 times negative 1, which is 10. Now this gives me the value of x, and that was one of my numbers. To find the value of y, I would substitute that into the equation we already had. Y is equal to 20 minus x, but we now know what x is, so y is equal to 20 minus 10, which is also 10. So the two numbers are 10 and 10. Let's look at example 6. A farmer has 600 feet of fencing. He will build a rectangular pen for horses using the barn as one side of the pen. A. What is the constraint equation based on the perimeter available? The constraint equation in an optimization problem is the amount of resources that you have to use. In this case, the farmer only has 600 feet of fencing. So that is a constraint on how large he can build his pen. The perimeter, based on the picture given, is x plus 2y. Now notice that that's not the normal perimeter equation for a rectangle. That's because the farmer is going to use the barn as one side of the pen, so he doesn't need fencing along the barn. He only needs fencing on these three sides. This perimeter is equal to 600 feet. Question B. Write the optimization equation, the area of the pin A based on both x and y. The optimization equation is the equation that you want to find the largest or smallest values for. In this case, we're optimizing the area of the pin, and since it's a rectangle, the area is length times width, which is x by y. Question C. Reduce the area equation to a function a of x, the area function in terms of x. When it says in terms of x, that means you'll have the variable x. And in this case, only the variable x. To do this, we're going to solve the constraint equation for y. So we're going to start with 2y is equal to 600 minus x, and then divide everything by 2. So y is equal to 300 minus 1/2 x. We take this equation and substitute it in for y in the area equation, and that creates a quadratic function a of x. A of x is equal to x times 300 minus 1/2 x simplifying, we get 300x minus 1/2 x squared and that's equal to 1/2 x squared plus 300x. So this is the formula for the area of the pin. Question D. Find the dimensions that give the maximum area of the pin, and what is the maximum area? So again, we're looking for the maximum. It's a quadratic. We know that the maximum occurs at the vertex. So we have x is equal to negative b over 2a. That would be negative 300 divided by 2 times negative 1/2. And if you figure that up, you get 300 feet. So the x side of this pin needs to be 300 feet in order to produce the largest possible pin. The y, the other side, can be found by using the previous formula. Y is equal to 300 minus 1/2 x. We now know what x is, so we can plug in our new value for x, which is 300. 300 minus 1/2 of 300 is 150 feet. So the dimensions are 300 feet by 150 feet. And that maximum area is found by multiplying these together. 300 feet times 150 feet gives me 45,000 square feet.